In May 2017, a Boeing 777 flying from Moscow to Bangkok struck severe turbulence. There was no warning. Passengers on board flight Su-270 were hurled against the roof of the plane. 27 people were badly hurt. The good news, the plane landed safely. The bad news, in some parts of the world, this kind of turbulence could become a lot more common. Let's explain. Turbulence is caused by chaotic eddies or currents of air. All sorts of things cause these disturbances: mountains, thunderstorms, even buildings. The location and topography of Wellington Airport, for example, can lead to particularly bumpy landings. There is, however, another type of turbulence that happens around the cruise altitude of commercial airliners. It's called clear air turbulence, and it can't be seen by pilots or easily picked up by radar or satellite. It's why one minute you could be cruising along, enjoying a movie, sipping a wine, and the next minute you're covered with your neighbour's in-flight meal. This is what caused the injuries on flight Su-270. Between 8 kilometres and 15 kilometres up, there are fast-flowing currents of air called jet streams. Jet streams move from west to east around the world and can reach speeds of several hundred kilometres per hour. Flights from North America to Europe are often affected by the jet stream that traverses the North Atlantic. These fast-moving rivers of air exist because of the contrast in pressure between the cold, dense air near the poles and the warm, light air at the equator. The pressure difference drives the winds, and the circulation of the atmosphere concentrates those winds in particular places to create jet streams. The greater the contrast in temperatures, the stronger they are. In recent decades, the Arctic has warmed dramatically, meaning the temperature difference between the cold polar air and the hot tropical air is smaller. You'd think that'd be good news for frequent flyers from New York to London. Lighter winds means fewer bumps, right? It's not that simple. While the temperature contrast is less pronounced close to the ground, something different may be happening above the North Atlantic where planes fly. The atmosphere isn't just one big fuzzy circle around the planet. It's divided into layers like a tiramisu. There's the troposphere, which extends from us down here on the ground up to around where airliners fly. Above that, there's the stratosphere. Jet streams are typically at their strongest where these two layers meet. Climate change appears to be warming the upper troposphere near the tropics and cooling the lower stratosphere near the poles. So why is the stratosphere cooling when the planet is warming? Well, think of the troposphere as a big winter coat around the Earth. All that CO2 we've released into the atmosphere has made that winter coat much bulkier and heavier, full of insulation, keeping all that heat in. So a thick troposphere keeps more heat close to Earth's surface and cools the stratosphere down. This suggests closer to the surface the jet stream is being pressured to slow down, but up high it might be under pressure to speed up. These competing changes can cause an increase in what's called vertical wind shear, which is a change in a wind's speed or direction over a short vertical distance. Imagine the plane is travelling along and suddenly the wind up there changes dramatically. Yes, you guessed it, really bad turbulence. So there you have it. We know flying takes its toll on the planet. It may be the planet is biting back.